This video is on Unit 6, Chapter 12, Exponential and Log Functions, Lesson number 3, Solving Logarithmic Functions. In this lesson, we're going to focus on solving logarithmic equations. The first type that we're going to look at is where we have a log on both sides of the equation. The steps here are going to tell you to first condense each logarithm. And what that means is if you've got an equation where you've got more than one log on each side or on a side, then we have to condense the logarithms together into one, like you learned how to do in lesson number 2. Step number 2 says to use the one-to-one property that says if log base b of m is equal to the log base b of n, then we know that m is equal to n. Basically, because you have matching logs on both sides, we're going to do what I like to call dropping those logs because they're the same, and you're left with m equals n. So let's look at example number 2. Let's start with number 2. Well, number 2 says log base 2 of 1 minus 4n is equal to log base 2 of 2n plus 43. You have one log on both sides. They're matching logs, so I'm going to get rid of the logs, and I'm left with 1 minus 4n equals 2n plus 43. Now I'm going to solve it. I'm going to add 4n to both sides. Subtract 43. I get negative 42 equals 6n. Divide both sides by 6, and we get n equals negative 7. The last step says to check for extraneous solutions. Now, what that means is I'm going to take that original log base 2 of 1 minus 4n, and n is now negative 7. So I'm going to check to see if that matches the right side, log base 2 of 2 times the negative 7 plus the 43. So let's go to the calculator. We're going to pull up alpha y equal, or alpha window, number 5, log base 2 of 1 minus 4 times, we got negative 7, and that gives me 4.857980995. Well, let's check the right side. Alpha window, number 5, log base 2 of 2 times that same negative 7 plus 43. Now, if this is true, which it is, those two numbers are going to match, and because the left side does equal the right side, this checks out, and n does equal negative 7. I'm going to jump down to example number 3. Example number 3 says log base 9 of 6 minus 3w is equal to log base 9 of negative 2w. One log on both sides, so again, we're just going to drop those logs and get 6 minus 3w equals negative 2w. Now, to solve this one, I would add the 3w and get 6 equals w. Again, we have to make sure we are checking these answers. So, log base 9 of 6 minus 3 times 6. And that's supposed to match the right side, log base 9 of negative 2 times 6. Now, just words of wisdom here. When I look at this myself, negative 2 times 6 is negative 12. I know that you cannot take the log of a negative number. And because you're not allowed to take the log of a negative number, this one is going to be no solution. Let me show you what happens in the calculator. The left side, alpha window number 5, log base 9 of 6 minus 3 times, we got 6 for that solution. And this is what happens. I get this complex number. There's an I out here on the end. So this lets us know real quick that this solution is a bad solution. It is an extraneous solution. So W does not equal 6. There's nothing else. So we're going to say no solution. Looking at example number 4, log of y plus 5 plus log of 4 is equal to log of 72. So the left side of this equation has 2 logs, which we need to condense into 1. And because there's a plus in the middle, we're going to use multiplication to put these 2 logs together. So it's going to be log of, you've got the y plus 5 times the 4, which is going to be 4y plus 20 is equal to log of 72. So all I did there was I condensed the 2 logs into 1 through multiplication because they were being added together. Those are the rules of logs, the rules of exponents. Now I can drop my logs and solve 4y plus 20 equals 72 minus the 20. 4y equals 52. And divide by the 4 and you get y equals 13. Y equals 13. Again, we must check this. So I'm going to take the 13 and I'm going to plug it in to the y. So that's going to be a 13. That's not a 1 over 13. The y becomes a 13. So let me cross out the y so that you don't think that that's a y. We're going to do log of 13 plus 5 plus log of 4. And then the log of 72 to check. Notice that there is no base, so I can use my common log button next to the 7. So I got log of 13 plus 5 is inside this parentheses, plus log of 4. And now I'm going to check log of 72. Log of 72, and they match. We got 1.857 on both of those. The left side does equal the right side, so y does equal 13. Looking at number 5, it looks like there's 1 log on both sides. The issue is the 3 that's in front of the log. So this is not in condensed form. What we have to do with this 3 is move it so that it says log base 7 of 4 to the 3rd power, log base 7 of the 4a minus 8. And we can even go one more step here. Log base 7 of 4 to the 3rd power, 4 times 4 times 4 is 64 equals log base 7 of 4a minus 8. Now we can drop those logs, and it'll say 64 equals 4a minus 8. So if we add the 8, we get 64 plus 8 is 72 equals 4a. Divide both sides by 4, and you get a equals 18. Again, you have to go back and plug that in. So for time's sake, I'm going to stop showing that step. I will make reference to it. But for the time's sake on this video, I'm going to let you know that 18 does work. So you would need to take that, plug that 18 back into the left side and the right side, and make sure that those 2 things match. Let's jump to example number 10. Example number 10 says log of 2 plus log of k squared is equal to log of k squared plus 16. The left side has 2 logs. We need to put them together through multiplication. So you're going to take the 2, multiply times the k squared. And the left side now becomes log of 2k squared. The right side is log of k squared plus 16. Now we can drop our logs, and 2k squared is equal to k squared plus 16. So we've got a quadratic. Because you have an exponent of 2, that means that we've got a quadratic here. We're going to solve by getting the k squares on the same side. 2k squared minus k squared is k squared equals 16. Now, couple of things we can do here. We can solve by we can solve by graphing. We can solve by quadratic formula. Or on this one, we can solve by the square root property. And I'm going to go ahead and use the square root property, and we can use the square root property when there's no bx. For those of you that remember when we solve quadratics. So we take the square root of both sides. The square root of k squared is k, and the square root of 16 is a positive and a negative 4. Now, you would have to test both of these solutions back into the original equation. So you have to plug it back in to the left side, the positive 4 into the left side and the right side. It should match. And then the negative 4 into the left side and the right side, and it will also match. I can tell you for time's sake that both the positive 4 and the negative 4 work. The second type of equation that we're going to look at is when you have a log on one side and a number on the other. The first step says to condense and isolate the logarithm. Secondly, we're going to write the equation in exponential form. Thirdly, we are going to solve and check for the extraneous solutions. So again, this goes back to lesson number 1 where we changed from exponential or logarithmic to exponential. So if it says log base b of x equals a in logarithmic form, in exponential form, it's b. Actually, I wrote that wrong. Hang on. Log base b of a equals x. In exponential form is b to the x equals a. So example number 11 says log base 2 of x minus 4 is equal to 6. Condense and isolate. There's only one log, and it's already by itself. So we're going to write this in exponential form, and it's going to say 2 to the 6th power is equal to x minus 4. 2 to the 6th power. You need a calculator. 2 to the 6th power is 64. So 64 equals x minus 4. Add the 4, and we get 68 for x. Again, you have to check for extraneous solutions. So plug the 68 in, and for time's sake, I will tell you that it does work. Let's jump down to example number, let's look at number 12. Log base 3 of 4x plus 8 minus 7 is equal to negative 3. So this one needs to be isolated. Do you see the minus 7? You've got to get rid of the minus 7. So we would need to add the 7 first and get log base 3 of 4x plus 8 is equal to 4. Now we're going to rewrite this in exponential form. So 3 to the 4th power is equal to 4x plus 8. 3 to the 4th power is 81. We're going to subtract the 8. 81 minus 8 is 73. Now, when we divide this by 4, it does not go evenly. X equals 73 over 4. Again, so that is a nasty looking fraction. You're just going to have to substitute that fraction in for x and see if it works. I will tell you that it does work. So the answer to number 12 is 73 over 4. Let's do one more. Let's look at example number 14. 2 times log of x minus log of 4 is equal to 2. So there's two things going on here on the left side of this equation. There's a 2 in front of the log, so I'm going to move that to the exponent. The next thing is we have 2 logs that we need to condense into 1. Now there's a minus in between, so we're going to use division. This is now going to say log of x squared over 4 equals 2. So we condensed it using division. Now we can rewrite this in exponential form. The understood base is 10, so 10 squared is equal to x squared over 4. 10 squared is 100. equals x squared over 4, and I'm out of room. We multiply by 4 on both sides. We get x squared equals 400. And then we're going to use our square root property to get x equals plus or minus 20. Now, again, for time's sake, I will tell you that the negative 20 is not going to work. Only the positive 20. So x is equal to a positive 20. And the way that you would discover that is by plugging that back in and checking that solution. So there's your notes for lesson number 3 on solving logarithmic equations.